Welcome back to today's session. Yesterday, we have solved the most simplest form of the game theory problem, which has saddle point. That is, we solved problems in which the problem itself has saddle points. Now, uh, there are some three problems which you can try it out and find out the optimal strategy for it as well as the value of the game, that is the saddle point. Now, the next problem that we actually try to study is the saddle point will not be available in the problem, right? They're called games without saddle points. Okay, these are also called mixed strategy problems. See, in a pure strategy, in the problem itself, your optimal strategy will be visible. So it is known to everybody. That is what we discussed yesterday, right? In the definition itself, it says if it is a pure strategy problem, it the next move is known to everyone. But when we talk about mixed strategies, straight away the optimal strategy or the saddle point will not be available. In the problem itself, you will not be able to find it because they are probabilistic in nature. So, based on a probability, the strategy has to be finalized. Okay, hope the concept is clear. So, now games without saddle points can be solved in three different ways. If at all the problem is a 2 cross 2 problem, if it has two rows and two columns, then to solve such a problem, we have a formula, right? So the problem will be solved by formula method. If it has two rows and more number of columns, or two columns and more number of rows, then directly the formula cannot be applied. So we will have to reduce the problem into a 2 cross 2 problem. So to reduce the given 2 cross n or m cross 2 problem, we use graphical method. By using graphical method, we will reduce this 2 cross n or m cross 2 problem into a 2 cross 2 problem. And then for that resulting 2 cross 2 problem, we apply the formula method and we will find out the solution. Okay. The next stage is you have m cross n problem. The problem is beyond formula method and the problem is also beyond graphical method. In that case, we have something called as a dominance property, right? By using dominance property, we will be able to reduce the rows and columns in the problem. So by using dominance property, we will try to reduce this m cross n problem into either a 2 cross n or m cross 2 problem. Or many a times what happens is the m cross n problem will straight away get minimized into a 2 cross 2 problem by dominance property itself. So if at all it gets reduces into 2 cross n or m cross 2 problem, then you will have to apply graphical method, then reduce it to 2 cross 2, then you will have to apply formula method and find the solution. If it is directly getting reduced into a 2 cross 2 problem, straight away you will apply formula method and find the value of the problem or value of the game. Okay, hope you have understood this concept. So whenever a game does not have a saddle point, first thing is we need to look into the dimension of the problem. If it is a 2 cross 2 problem, apply formula method. If it is 2 cross n or m cross 2, apply graphical method. If it is m cross n problem, apply dominance property. So this is the first step in solving games without saddle points. So in today's session, I will be teaching you only 2 cross 2 problem, right? First, I'll give you the formula. Then we will take one problem and try to solve it using the formula method and see how it is calculated. So in tomorrow's session, we will see graphical method and how we reduce the problem into 2 cross 2, and then you will be knowing how to apply formula method for it, and you will be able to arrive at the solution very easily. Okay? Is it acceptable? Shall we go ahead? So now we will go into 2 cross 2 games without saddle point. So whenever you have a 2 cross 2 game, which is a 2-person zero sum game without a saddle point, so we will assume the matrix to be of the form A11, A12, A21 and A22. Okay? Why am I giving names to it? Because we can use these names in the formula. That is why we are considering the general payoff matrix of a 2 cross 2 game as A11, A12, A21 and A22. Right? So the goal of the problem, why are we actually solving this problem? So the goal of the problem is to find three things. One is optimal strategy for A, optimal strategy for B, and the value of the game. Okay? Three things we are supposed to find out. So what is the optimal strategy for A? The optimal strategy of A is defined by P1 and P2. These are the probabilities. Okay? The optimal strategies are the probabilities P1 and P2. And similarly for player B, we will find out two optimal strategies with probabilities Q1 and Q2. So the formula for computing P1 is A22 minus A21, A22 minus A21 divided by principal diagonal minus secondary diagonal. A11 plus A22 principal diagonal. A11 plus A22 minus A21 plus A12. So the secondary diagonal. Principal diagonal sum minus secondary diagonal sum. That will be the denominator. So the numerator will be the lower row or the last row, A22 minus A21. Okay? What about P2 then? P2 is, because they are probabilities, the total probability has to be 1. So if we have found out P1, P2 can be easily found out. It will be 1 minus P1. So P2 is 1 minus P1. So let us have a look at the formula for Q1. So here it is last column, A22 minus A12. See, when I go with P1, it is last row. When I go with Q1, it is last column, A22 minus A12, divided by, denominator will be the same, principal diagonal sum minus secondary diagonal sum. A11 plus A22 minus A21 plus A12. Okay, this will be your Q1 formula. So once you have found out Q1, finding Q2 is very simple. It will be 1 minus Q1. Then for the value of the game, which is denoted by gamma, right? We use a notation called gamma. This is written like uh, this. Okay, 1 minute. The length increased. I'll rewrite it. Okay. So this is the gamma notation. So we denote value of the game by gamma. Okay. So gamma is given by principal diagonal product minus secondary diagonal product divided by sum of the principal diagonal minus sum of the secondary diagonal. So that is A11 into A22 minus A12 into A21 divided by A11 plus A22 minus A12 plus A21. Okay. So these are the three formulae that you should remember. If at all you are supposed to solve any problem in game theory, these are the three formulae that you should remember. Very important. Because whether it is 2 cross 2, you will have to know the formula. If it is 2 cross n or m cross 2, you will reduce it to 2 cross 2 and then once again apply the formula. If it is m cross n also, you will reduce it to 2 cross 2 and then apply the formula. So whatever might be the type of the problem, the formula should be known to you. Therefore, these three formulae you should remember. Okay. So shall we have a look at a numerical problem and see how it is solved? So we'll take one problem. Solve the following payoff matrix. Determine the optimal strategies and the value of the game. The game is 5-1-3-4. So by default, the matrix will be noted as A11, A12, A21, A22. So A11 is 5, A12 is 1, A21 is 3, A22 is 4. Okay. The optimal strategies are given by P1 and P2, and for player B it is given by Q1 and Q2. So first let me compute P1. P1 is equal to A22 minus A21. So which is 4 minus 3 divided by principal diagonal sum A11 plus A22, that is 5 plus 4, minus secondary diagonal sum A12 plus A21, 3 plus 1. Okay. So that is what I have written here. 4 minus 3 divided by 5 plus 4 minus 1 plus 3. 4 minus 3 is 1. 5 plus 4 is 9. 9 minus 1 plus 3 is 4. 9 minus 4, 5. So I get a 1 by 5. So P1 is 1 by 5. So what will be P2? P2 is 1 minus P1. 1 minus 1 by 5, which is 4 by 5. Okay. So we have now computed the optimal strategies for player A with probabilities 1 by 5 and 4 by 5. Now look at optimal strategies for Q, that is for player B. It will be Q1 and Q2. So compute Q1. So it is A22 minus A12, last column, divided by sum of the principal diagonal A11 plus A22 minus A12 plus A21. Okay. So it will be 4 minus 1 divided by 5 plus 4 minus 1 plus 3. So 4 minus 1 is 3. So this denominator is the same in both the cases. So I get a 5. So it is 3 by 5. So Q1 is 3 by 5. So what happens to Q2? So Q2 will be Q1 minus Q1. Right? It will be 1 minus Q1. So 1 minus 3 by 5 will be 2 by 5. So I have found out the optimal strategies of A to be with probabilities 1 by 5 and 4 by 5. Optimal strategy of B has the probabilities 3 by 5 and 2 by 5. Now I am supposed to find out the value of the game gamma. So it is product of the principal diagonal minus secondary diagonal. A11 into A22 minus A12 into A21. So it will be 5 into 4 minus 3 into 1 divided by sum of the principal diagonal minus sum of the secondary diagonal. 5 plus 4 minus 3 plus 1. So it will be 5 into 4 minus 1 into 3 divided by 5 plus 4 minus 1 plus 3. 5 4s are 20. 20 minus 3 into 1 is 3. 20 minus 3 is 17. So here denominator is always the same. So denominator will be 5. So the value of the game is 17 by 5, or you can write it as 3 2 by 5. Normally we don't write it in mixed fraction, we write it in the improper fraction itself. So the value of the game is 17 by 5. Any doubt with this problem? Isn't it very simple? Only thing is you need to remember the formula correctly. So shall we check by solving another problem? We'll take another problem and try to solve it. So the problem given is solve the following payoff matrix, determine the optimal strategies and the value of the game. The game is 4 minus 4 minus 4 4. So A11 is 4, A12 is minus 4, A21 is minus 4, A22 is 4. Okay. So the formula is A2 for P1, the formula is A22 minus A21, which is 4 minus of minus 4, which will be 4 plus 4, divided by A11 plus A22, which is 4 plus 4, minus A12 plus A21, minus 4 minus 4. This will be minus 8, minus into minus plus. So 8 plus 8, 16. So I get 8 by 16, which is half. So if P1 is half, P2 will be 1 minus half. 1 minus half is once again half. So P1 is also half, P2 is also half. So look at Q1. Q1 is A22 minus A12 divided by A11 plus A22 minus A12 plus A21. So which will be 4 minus of minus 4 divided by 4 plus 4 minus minus 4 minus 4. So once again you get a 8 by 16. Once again it is a half. So if Q1 is half, Q2 will be 1 minus half. So which is once again a half. So what does it mean? The optimal strategies of A has the probability half and half. The optimal strategies of player B also has probabilities half and half. Everyone is equally likely to win the game. Then what would happen to the value of the game? If everyone is equally likely to win the game, the value has to be 0. So that is what we will check by applying the formula. So A11 into A22 minus A12 into A21 divided by A11 plus A22 minus A21 in plus A12 is 4 into 4 minus of minus 4 into minus 4 divided by 4 plus 4 minus minus 4 minus 4. So this will be 4 into 4, 16, minus minus 4 into minus 4 is also 16. 16 minus 16 will be a 0. So numerator is 0, denominator is 16. So 0 by 16 is a 0. So the value of the game will remain 0. Hope you people have understood and also enjoyed this 2 cross 2 game. Isn't it simple? Okay. So thank you for your patient listening. Have a nice time. Enjoy. Kindly be at home and be safe. Thank you. Bye.